continuing on with class number 10. This semester it's class 10. Here is an example, Shigley Problem 11.1. And we have for a certain application requires a ball bearing with the inner ring rotating, which is usually the way it goes, but we can have that arrangement where the outer does, with a design life of 25 kilohours at a speed of 350 RPM. The radial load is 2.5 kilonewtons and an application factor of 1.2 is appropriate. The reliability goal is 90. Okay, so 0.9, which is usually the case. That's like the standard thing for us, is we're going to go reliability of 90. We're about to change that in the next section. For the multiple rating life required XD, and find the multiple rating life required XD and the catalog rating C10 with which to enter a bearing table. Choose an O2 series deep groove ball bearing from table 11.2. Now table 11.2 is like an excerpt from a manufacturer's catalog. So we'll take a look at that right there. So you'll see here's like the little excerpt from catalog 11.2. So this is what we're going to try to do. We're going to try to find a C10 rating right here out of that catalog. That's why they're saying take a C10, and they say to use an O2 series deep groove ball bearing. And so this right here tells us that it's an O2 series, and you might ask, what is an O2 series? And somewhere in here I should have where that is located right there, right, with the different it's like the proportions of the thing. Also, something I didn't introduce in when discussing here, I introduced you to this application factor right here. I wanted to point out in the book that there's a table 11.4 where it has this application factor, which is just a multiplier that we would use when entering in here. So sometimes we want to multiply a number by it. So this is sort of like the most generic of the equations as I was trying to introduce them. And while we're here, let's take a look and see what that O2 series means, because that seems like we just introduced it, and if I were you, I'd be like, well, what does that mean? And I'd be like, well, I'll show you what that means, because I'm a professor, and that's my job, is to see the thing here. And I don't see it in here, so wait a minute. Where did you go? Oh, here it is. So here is what an O2 series is. See that right there? These proportions right there, where here is here's the bore right here compared to the outer diameter compared to the thickness right there, right? So that there's going to be like so here's like an O width series, right? And so you can see that, and here's a 1 width series. So you can see that the width changes, but also the proportions right there. So it's because you got to fit it into a machine, so they kind of classify them there. But you also have, like, so here is your here's the table from the 11th edition right here, and we can see that we have a rated load which is given by C's right here that are in kilonewtons. So this is what we want, and you can see that they're done by bore, right? So so for the inside diameter of this thing is what the shaft that it's going to fit on is based on right here. And now you could see what you could pick for this O2 series, this sample catalog. You can pick out a bearing for it. So let's go to the problem right here. The first thing that we're going to do is get this XD that I referred to, right? So they're asking for this multiple rating life, and that XD is simply going to be LD over LR. I don't know why I started to make that an F on accident. Okay, LR. And so let's see, this they say, oh, they introduced the application factor right there of 1.2. So we needed to, that's the reason why I brought this thing up. You could see, so that they've decided, they gave it to us somewhere in here that they had 1.2. So that it was like a given type of thing. and I'm looking for the reliability goal is 90, and I guess we're going to assume that this thing is going to be 1,000,000 right here, this rated life. Let me point out to you another table that we will want to look at in Shigley's scenarios. Here we have two manufacturers, two mythical manufacturers. One of them's manufacturer 1 and one of them's manufacturer 2. Manufacturer 2 bases their life on 1,000,000 revolutions, whereas manufacturer 1 uses 90 million, right? So they're running their machines and testing their bearings, right? They have the individual test machines, and they're running a bunch of them so they can get a statistical significant number of failures to be able to set what this rating is going to be. So, but we're going to choose that it's manufacturer 2. That's like the typical thing most often we pick. So we're going to pick on the denominator, that's just going to be 10 to the 6th. On the top, we're going to say that we're going to have 60, right? So 60 is a conversion. We're going to have our 350 RPM, and they want it to last for 25,000 hours. So now we have cycles divided by cycles, right? So 25,000 hours. So here is how many revolutions per minute, but now we change it to revolutions per hour. So now we figure out how many revolutions we're dealing with right here. So there's 525 is the ratio, right? So, and it's quite often we want it to last a lot longer than 1,000,000 cycles. So that tends to like so the load that we're going to put onto this thing, we're going to have a radial load of 2.5. So we're going to find our C10. We're going to use this equation right up here and take an application factor. We're going to take our rated, or our thing right here, 525, and we need to multiply it by the FD. The FD is the 2.5, and we're going to get kilonewtons, so that's a good thing. We're going to take our 525 and raise it to the 1/3 right here, and what we find, we get 24.20 kilonewtons, right? And so now he says, look this up. So we look it up in the catalog, and in the book right here, let's look at the real book that we have for this thing. And here's our catalog, right? So here's what we have for ball bearings, and we come down, and they said that they told us they wanted a deep groove, right? They wanted a deep groove, so that's going to be this one right here. And we come down in our 24.2. We see, ooh, look at this. This can handle 25.5. So we look over here, we see that's a 35 millimeter bore. So what we end up saying is, so 35 millimeter works. So we specify it's an 02 35 deep groove ball bearing. And so what we do when we put a bill of materials together for our machine, we make sure that we specify this. We might even specify a manufacturer or suggested manufacturer, and then the purchasing agent for our company looks and they try to find maybe the best deal that they can get on these. For us, let's see, we can also look this up in a real catalog. So here's one by NSK. I don't know if I put this in here so where I can actually find it. So we have a bearing rating life of C10 right in here. Let's see. These are in newtons, this basic load rating right here. Why would I show this catalog if I didn't have one that could handle it right here, right? So you could actually see these are like other designations about different things that we might want to know, just to point out that this is more complicated than just what we're doing here. But I'm trying to see in here what my point was. I include the excerpt in there. It seems to me that I would have made this so in such a way that we could have found our bearing in there. That would have made a lot more sense than just to randomly take. There's the 35 millimeter one right there, and I'm looking for my C10. Okay, so right here we see that 25.7 right there. Okay, so here's my CR. I don't think it's actually called a C10 in this particular one. This is from the Timken one though instead, and you can see that they have a static load rating, but they also have extended dynamic load rating right over here. So this is, I think this is going to be the same one as ours, and you can see for the 35, no, they have like a 29.1 kilonewton rating right in here. But this is like the idea, the same idea that we have. So here's a sample SKF catalog, and this is like an online thing right here. And you see the basic load ratings right here, and we can see the limiting speed. So there's other things within the catalog, right? So what we're doing is really sort of a simplification. And in each of these catalogs, there's a section that'll tell you the process to go to go filling these things out right here. So that's my example 11.1. I've given you a lot of information. Hopefully you're more familiar with bearing selection right now, and we will go on and do the next section.